Hello and welcome to the 7th lesson in the second part of statistics in the Year 11 Standard Maths course. Today we are looking at parallel box and whisker plots. So what is a box and whisker plot? Well, a box and whisker plot is just a graph, and it's a graph of 5 specific numbers from a data point, and the 5 numbers are the lower extreme, so the smallest number, the lower quartile, Q1, the median, so that middle number that we've been looking at before, Q2, the upper quartile, Q3, so the piece of data that's 3/4 of the way up, 75% of the way. Those percentages can be important. And finally, the biggest number in the data set, the upper extreme. Why do we use it? Well, it's just an easy way to compare two, or more, in fact, really, related data sets. So particularly in something like a school setting, box and whisker plots for the results of the Year 11 standard classes over the course of the year when they've done their HSCs or the preliminary exams could be a really good way to see how different classes are doing, how they're comparing, and perhaps see if things, there are lessons that can be taken from one group to another. So we'll have a quick look then at how you would plot them on the next slide. So on this slide we have a couple of fictional maths classes to consider. Class A have got their result at the top, Class B have got their results underneath. On both lists we are asked to circle and label the 5 numbers that are needed for a 5-number summary. So that's those 5 numbers that we had before. The way I would do these is to start with the median, start with the middle, then do the quartiles, then do the lower extreme, the upper extreme from there. I'll just show you how that works. So if you count the number of pieces of data in class 1, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. So the position of the data that's the median is halfway between the first and the last piece of data, so just up on the corner here. So the position of the median is 1 plus 11 over 2, so it's the 6th piece of data. If you count the pieces of data from the left to the right until you get the 6th, you'll find that 11 is the median. If you do a similar thing for the numbers below, you'll find it's the 8th piece of data, and 12 is the median. So let's write those in below, 11 and 12. The lower quartile for Class A has a look at the list of the 5 numbers to the left of the median, and it says, okay, what's the middle of those 5 numbers? The middle of the 5 numbers is the 3rd number, so it's 7, and then the upper quartile is the 3rd number on the list to the right, so 7 and 14. For Class B, there are 7 numbers on the left and on the right of the median, so the 4th number is halfway between the 1st and the 7th, so the 4th number is 6, and the 4th number over here is 18. Finally, the lower extreme and the upper extreme are really easy to read off the list. The lower extreme for Class A is 5, and the biggest number, the upper extreme, is 16. And for Class B, the lower number is 3, the biggest number is 20. So we've got our 5-number summary filled in. Of course, if you're asked to do a 5-number summary for a set of data, make sure they're in order before you start. I've given you an example where they are just to save time, but if they're not, just rewrite the list with the numbers in order first. Okay, so if you turn over the page, we will now plot these pieces of data as a box and whisker plot. So as a quick reminder, for Class A, we had the results that the lower extreme was 5, Q1 was 7, the median was 11, Q3, the upper quartile, 14, and the upper extreme was 16. The way I plot all of these is to draw a vertical line at the points we were given. And I usually like to go over 2 squares. so that we can get the whiskers in the middle. Some books won't do the vertical lines at the end, they will just do dots. That's okay, either one would be accepted. And this one also matches the textbook if you do it this way as well, which is quite handy. Okay, so there are the 5 data points. The whiskers just join the quartiles to the lower and the upper extreme. And then the box joins the quartiles together and has the median inside it as well. So I've just drawn these lines extra thick to make sure they stand out. You don't necessarily have to do the same as long as you can read it. And then what we will do is we will just label at the side which class this is. So this was class A. Okay, so for class B, parallel box and whisker plot means they should be on the same side of the axis. So we're going to put them both above the axis here. So 3, 6, 12, 18, and 20. Once again, the whiskers join the quartiles to the extremes, and then the quartiles themselves are joined up by the box, like so. And then, once again, we just label which class this was off to the side so people can read it easily. Okay, so other important features of a box and whisker plot. Notice we've got a labelled, so I've labelled that this is showing scores, numerical axis along the bottom, so all the numbers are there. You don't necessarily have to put every number, you can just do 0, 2, 4, 6, etc. Just the even numbers, as long as it's still easy for people to read. The more accurate you are, the better though. And there are some other ideas around this, so sort of analysis of the box and whisker plots. If we were asked to compare these two box and whisker plots, what might we say? Well, as we said previously when comparing data sets, really they're looking for 2 things. They're looking for you to use a measure of location, and they're looking for you to use a measure of spread. So what we could say is that on average, one example of that is the median. So if we compare the 2 medians, Class B's median was 12, Class A's median was 11. So on average, Class B scored better. So Class B's teacher might say, great, my class was better on average. However, we can put however. In terms of then the range, the word they usually want to see coming out is consistency. So in Class A, you'll notice that the scores, the box and whisker plot, it's much smaller. Class B is a wider box and whisker plot. So what that means is Class A were more consistent. And if you're asked to justify those statements, so the first statement, it is a higher median that justifies that Class B were better on average. For the consistency, it is all about the lower range of scores. So the range of Class B scores was 20 minus 3, 17. The range of Class A scores, 16 minus 5 is 11. So Class A had a lower range. Similarly, they also have a lower interquartile range. Okay, so that's that. One of the other things that may come up with box and whisker plots is just to remember that between each sort of vertical line on the box and whisker plot, 25% of the data is held there. So 25% of people will fit between the lower extreme and Q1, 25% will fit between Q1 and the median, 25% between Q2 and Q3, and 25% will fit between Q3 and the upper extreme. Remember, these are quartiles. We're plotting the three quartiles and the extremes, so it's dividing everything into quarters. So if you were asked to do an estimate in Class A, how many people scored between 11 and 14 marks, so this section here, between 11 and 14, reading from the bottom, you would say that it was 25%. If they said there were 60 people in the class, roughly how many people scored between 11 and 14, and you didn't have the list, you just had the box and whisker plot, you'd work out what is 25% of 25% of 60 people in the class, which is 15, and say that approximately 15 people scored that. So that is also analysis that came up in year 10, and you may want to go back and refresh yourself if you found that hard first time. Okay, so what you'll need to do in class is complete exercise 10F. If you've got some graph paper with squares, that'd be really useful because you'll be drawing a lot of box and whisker plots and it makes the plotting much easier. Otherwise, ask your teacher if you've got any questions about the video or any extra ideas, things you need to cover off, and we will have just one more lesson after this. Okay, thanks very much.